Today, lesson 13a, we continue working with inequalities. Today, like yesterday, we go a little more in depth on working with inequalities. And so tomorrow, we will be finishing up this idea of inequalities, and then on Friday we'll have a test. And tomorrow, on Thursday we will go. On Thursday we will go into full detail on exactly what will be on Friday's test. So what have we done so far with inequalities? Well, we've done a lot of solving, and of course sometimes you have to remember to flip the inequalities, sometimes you don't have to. If you're asked to, you need to graph the solution set for the inequalities. And then when we're dealing with word problems, we need to remember that some word phrases mean different inequalities. And we have all of that stuff in our notes from a few days ago. All right, so today, Joaquin and Serena work together productively in their math class. They both contribute their thinking, and when they disagree, they both give their reasons and decide together who is right. In their math class right now, they are working on inequalities. Recently, they had a discussion that went something like this, and this is a lot of what we do when we do our shoulder partnering. So Joaquin says that 6 less than a number is greater than 4. And I gave you some problems like that, I think 2 days ago in the homework. I think that we should follow the words and write 6 minus x is greater than 4. Serena then says, I don't think that works because if x is 20 and you do 6 less than that, you get 20 minus 6, which equals 14. I think we should write x minus 6 is greater than 4. Joaquin follows that up with, oh, you're right. Then it makes sense that the solution should be x is greater than 10, which means we can choose any number greater than 10. So what's going to happen here is I'm going to give you a situation. You're going to have to decide who is right and be able to reason why whoever you think is right, come up with some reasons in words or using math. So we'll start with some very simple ones here, and all of these are written in your notes. So here's number 1. Joaquin and Serena are assigned to graph the inequality x is greater than negative 7. Joaquin thinks the graph should have an open dot at negative 7. Serena thinks that the graph should have a closed dot at negative 7. And obviously there shouldn't be two ats right before the negative 7. Explain who is correct and why. Well, this one is a super easy one. Who is correct, Joaquin or Serena? Joaquin. Anytime we're asked to graph greater than or less than, it has to be an open dot because it does not include the number, whereas if it's a closed dot, it has to include the number. So when we answer these, that's the type of explanation that we need to use. Okay, let's go to number 2. Joaquin and Serena are looking at the problem 3x plus 1 is greater than 0. Serena says that the inequality is always true because multiplying a number by 3 and then adding 1 to it makes the number greater than 0. Is she right? Explain why or why not. So I want you to think about that for a second. Is she right? No. And in fact, if you were to take that inequality and solve it, you would get x is greater than negative 1/3, so that's what x would have to be. So if you just plugged in negative 1, for example, that side is not greater than 0. Okay? So we've kind of done a couple together. Let's check out number 3. The word problem that Joaquin and Serena are working on says 4 greater than x. Joaquin says that they should write 4 is greater than x. Serena says that they should write x plus 4. Explain who is correct and why. I want you to answer that, and then we'll shoulder partner this one. Natalie, who's correct?
Serena.
Why?
Because it says 4 greater than x instead of 4 is greater than x.
Is Serena the one who's correct?
Yes.
Really?
Yeah.
4, there's 2 different things going on here, okay? If we have 2 ways of changing this up. If I said 4 is greater than x, that means one thing. This means one thing, this means something totally different. So the question is, which one means x plus 4, and which one means 4 is greater than x? Now, I'm not saying you're wrong. I'm just saying I want you to be very sure. Which one does this mean? Does this mean 4 is greater than x or x plus 4? Which one? That means x plus 4. This, because of this part right here, this word is, that means x. Whoops, didn't draw my arrow all the way there. That means that right there. So who's right again? Serena is correct. Good. All right, let's go to number 4. Joaquin is thinking about hard equations and inequalities and comes up with this idea. 45 plus 47 equals t, and then t equals 45 plus 47. So, if 45 plus 47 is less than t, then t is less than 45 plus 47. Is he right? Think about that for a few seconds. Answer it, and then we will shoulder partner this one. All right, twos will take this one. Go. All right, bring it back up here. So, is he right? No. While it's obvious this is true, these two things mean totally different things here. One can't be true and also the other true. It's true in the equation part, but not necessarily the inequality part. So Joaquin is not correct because those two things are not equivalent to each other. All right, now we're going to do two at a time. Everybody do number 5 and number 6, please. Number 5, there are all kinds of things happening here, and it's a point that I made when we first started reviewing inequalities. The solving part of solving inequations or inequalities and equations they're identical to each other. So in other words, if you were to solve both of those, you would probably multiply both sides by 3 and then divide both sides by -1. So the solving part is identical. Where they differ is the equation has one answer or one solution, but the inequality has many solutions. If you solve that inequality, you end up with x is less than -12. There are many numbers. In fact, there are infinite number of numbers that are less than -12. So that's how they are the same and how they are different. In number 6, we were asked if, let's see here, Joaquin solved that by adding 15 to both sides. I think it's obvious that that's not what you're supposed to do. You're supposed to divide. So obviously Serena is correct because you're supposed to divide or use the inverse property, which would mean you would need to divide on that. Okay, so here's what we're going to do for the rest of the problem. Let's turn over to the back side. I want you to work with your shoulder partner for the rest of these problems. I'm going to check back with you in about 7 or 8 minutes, and then we'll quickly go through 7 through 11. So you have about 7 or 8 minutes. Work with your shoulder partner on these. Number 7, it's asking if Joaquin is right. Whatever he's saying up there does not prove that he is correct. A solution of Q is less than or equal to 150 means that all the numbers less than or equal to 150 will create a true statement. And that's just not going to happen the way that he solved that inequality. Number 8, it's asking if Serena is right, and she is not. The mistake that she made was she did not add 2x to both sides. She subtracted 2x, which of course you can't do that, because if you subtract 2x right here, those are not canceling out, so we've got big problems right there. Number 9, it's saying that those two are having trouble with that. Explain how they should solve the inequality, showing all the necessary steps. And so you had a table there, so that one should have been pretty easy. Use the distributive property, subtract 2m from both sides, divide both sides by negative 14, which of course means you'll have to reverse the inequality symbol. And so we should end up with m is less than negative 1/7. Number 10, we had 3 inequalities here, and basically that's a summary of something that we did a few days ago. Part A, the answer should be all real numbers because the variables cancel out, and we end up with a true statement. If you are to graph that, that would be a number line where the entire number line is covered. Part B, same thing, all real numbers, because what we end up with is a true statement. 5 is greater than negative 2. The graph covers the entire number line. Part C, we end up with a false statement with the variables canceling out. We end up with 1 is less than negative 3. That obviously is not true. And the graph of a no solution inequality means a number line with nothing above it. Okay? All right, we are finished.